Hello viewers, here is Dr. Mala Das Sharma. Welcome you to my tiny YouTube channel MALACHEMPHILIC. Today I am going to start video number 126 and video number 126 is the riddle number 61 and this riddle is based on the partial molar property and the phase equilibrium. So here is riddle number 61. The thermodynamic state function A that depends on temperature, pressure and composition of the phase is the ratio of infinitesimal changes of two extensive properties. Under certain condition, its value becomes equal to another thermodynamic function which is considered as indicative of spontaneity. The function A determines whether there is material equilibrium between the phases or not. So, this is riddle number 61. Now, let's see the multiple choice question associated with this riddle. Question number 1. Which thermodynamic function is referred here as A? The options are option A, partial molar volume, option B, entropy, option C, Gibbs free energy, option D, chemical potential. The correct answer is option D, that is chemical potential. Now question number 2. What are the two extensive properties as mentioned in the riddle? The options are option A, Gibbs free energy and number of moles of the concerned component, option B, entropy and number of moles of the concerned component, option C, enthalpy and number of moles of the concerned component, option D, work function and number of moles of the concerned component. So the answer is option A, that is Gibbs free energy and number of moles of the concerned component. See, chemical potential of the ith component, that is mu I, that will be is equal to dou G by dou Ni at constant temperature, pressure and the composition of other component. So what does it mean? Chemical potential of ith component, that means contribution of the ith component towards this total properties, total Gibbs free energy of the system. And its definition is, see here, it is change of Gibbs free energy with per mole change of the number of moles of that component at constant temperature, pressure and the composition of other components. So, it is the ratio of two extensive property. One is Gibbs free energy, another one is number of moles. Okay, and infinitesimal changes. Ratio of infinitesimal dou G by dou Ni. Ratio of infinitesimal changes of this Gibbs free energy and number of moles. Now let's move to the third question. Question number 3. Under what condition its value becomes equal to another thermodynamic function which is considered as indicative of spontaneity and what is referred here as another thermodynamic function? The options are another thermodynamic function is Gibbs free energy and the condition 1 mole of pure substance. Option B, another thermodynamic function is entropy and the condition 1 mole of pure substance. Option C, another thermodynamic function is enthalpy and the condition is 1 gram of pure substance. And option D, another thermodynamic function is work function and the condition is 1 gram equivalent weight of pure substance. Now let's see the answer. Answer is A, that is another thermodynamic function is Gibbs free energy and the condition is 1 mole of pure substance. So here we have seen just now that chemical potential, say mu I, that is equal to dou G by dou Ni at constant temperature, pressure and composition of other components, right? Now, if it is number of mole is 1, Okay, so number of moles is 1 and it is a pure substance. Pure substance means only one component. And if it is a pure substance and number of moles is 1, then what will happen? Then this mu, for pure substance, it will be mu only. No need to write the component name, pure substance. Then, and number of moles is here 1. Then mu will be is equal to G. So, under the condition, what condition? Pure substance and 1 mole of the substance, this chemical potential is equal to this. We can write molar Gibbs free energy, and we know that Gibbs free energy is the indicative of spontaneity of the process or reaction. Now coming to question number 4, how can you identify material equilibrium between the phases using this function? Option A, at material equilibrium, chemical potential of all the phases are equal. Option B, at material equilibrium, chemical potential of all the phases are 0. Option C, at material equilibrium, chemical potential of all the phases are less than 0. Option D, at material equilibrium, chemical potential of all the phases are greater than 0 but less than 1. Let's see the answer. Answer is A, that is at material equilibrium, chemical potential of all the phases are equal. Okay. See, if you consider that, say here, you are plotting temperature versus pressure plot, and if you consider this line is a equilibrium, indicating the equilibrium between the two phases. This is phase alpha and this is phase beta. Okay, and as it indicates equilibrium between the two phases, that means at every point on this line equilibrium exists. That means two phases coexist. Okay. Now, so at every point on this line, that means when the equilibrium is present between the two phases of the same substance, say this two phase may be, say I'm telling you that solid and liquid equilibrium of a particular substance, say water, ice and water. Okay, then at equilibrium, these two phases are in equilibrium means they must be at thermal equilibrium, mechanical equilibrium, and they must, thermal equilibrium, mechanical equilibrium, and they must be at material equilibrium. Material equilibrium means that this substance, it is a pure substance, the chemical potential at phase alpha must be equal to chemical potential of phase beta. So, is the chemical potential of the substance should be equal in all the phases. Okay. Hope you have enjoyed. Thank you.